Dear viewers, welcome to the YouTube channel H2O Chemistry. In this video, we are going to learn the topic called Reactivity Series and Type of Ores. Let's go to the first topic, Reactivity Series. It says Reactivity Series. The metals are arranged based on their reactivity in a series is called reactivity series. In the series, the top position is occupied by potassium, the last position is occupied by gold. The series consists of potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, hydrogen, copper, mercury, silver, platinum, gold. The hydrogen is taken as a standard. The reactivity of hydrogen is taken as a standard, above which they are called reactive, highly reactive metals. Below hydrogen, the metals are least reactive metals. So this is an idea. When we move down from the top to bottom, the reactivity of the metal decreases. What is the one more point you have to understand this? In the top we have potassium. When the potassium reacts with sodium chloride, for example, the potassium can replace sodium in sodium chloride. So NaCl plus K will give you KCl plus Na. It means the potassium is highly reactive than sodium. So what is the concept you are learning here? The potassium can replace all other elements. Come to the next case, sodium. Sodium can replace all other metals which is mentioned below, but not the potassium. So when you go down, the reactivity of the metal gets decreases. Aluminium can replace zinc, lead, iron, hydrogen, copper, like that, but it cannot displace magnesium, calcium, sodium, potassium in their compounds. So that is the idea. It's otherwise called activity series too. Okay, what is the relationship between this reactivity series and our metallurgy process? See, the metallurgy process is the extraction of metals. So this series is very helpful for us in determining the extraction of metal from their metal oxides. It is otherwise called smelting, reduction of metal oxides from metals. I say reduction. What do you mean by reduction? Removal of oxygen is called reduction. Could clearly say here, metal oxides, when you remove oxygen from metal oxides, we get metal. So removal of oxygen takes place. So this process is called reduction. So this reduction process is carried out in many different ways depending upon the reactivity of the metal. So depending upon the reactivity of the metal, we can predict which reduction method we want to choose. On the top of the series, we have potassium, sodium, calcium, magnesium, aluminium. So this is we call highly reactive metals. These highly reactive metals can be reduced by only electrolysis. Okay, what do you mean by electrolysis? Electrolysis means, electro means electricity, lysis means breaking. So we are breaking the ore or metal oxides with the help of electricity. So that is called electrolysis. For example, let us say potassium or sodium, magnesium, we will see. This metal oxides, potassium oxide, sodium oxide, calcium oxide, magnesium oxide, aluminium oxides cannot be reduced by conventional reducing agents like coke, carbon monoxide and hydrogen. The reason behind this, these reducing agents cannot produce much energy to break the metal oxide bonds, metal oxygen bond. So the metal oxygen bond broken means we get metals. So these carbon monoxide hydrogen cannot produce so much of energy to break this bond. So this method doesn't work for this highly reactive metals. Okay, how does this electrolysis process carried out? We will see. See, this method is adopted for the top of the series. Now, this electrolysis tank. In this tank, we used to have two metal electrodes. Usually, the pure metal is taken as a cathode, impure metal is taken as an anode. The solution which we take is nothing but we call electrolytes. Electrolytes are chosen based on the metal. So if I take impure metal in the anode, the solution should contain the same metal solution. That means if I take sodium, impure sodium as an anode, the solution should be a salt of sodium, for example sodium chloride, like that. So if it goes, so the electrodes are connected with the battery. If I supply voltage through this, the solution consists of Na plus ions and Cl minus ions. The electrodes which is connected to the positive end of the battery is called anode, negative end of the battery is called cathode. So the sodium present in the solution attracted towards anode because sodium carry positive charge, cathode is negative. So sodium gains electron from cathode and deposit as a sodium atom. Similarly, chlorine goes to the anode and it takes up the sodium and forms sodium chloride, and then it dissolves in the water, again sodium forms. This process is repeated. So what we should know is metal gets deposited at the cathode because metal is positive ion, cathode is negative ion. The very similar procedure if you adopt for magnesium chloride. The cathode we take is pure magnesium, the anode is impure magnesium. So the magnesium present in the respective electrolyte we call the magnesium chloride. If you take the magnesium present in the solution will go and deposit in the cathode. The magnesium 2 plus will gain 2 electrons and will deposit as a magnesium atom in the cathode. So this is the idea, my dear children. So the metal gets deposited in the cathode. You could see here the potassium gains electron from cathode and convert into potassium atom. So potassium atom at the cathode. What about in the middle of the series? It's somewhat less reactive than the top of the series. So it can be reduced only by reducing agents such as coke, carbon monoxide, hydrogen, like that. For example, zinc oxide. So we know that zinc sulfide we call galena. The galena ore is concentrated by 4-flotation method, and then to convert the zinc sulfide into zinc oxide we do roasting. After roasting, zinc sulfide converted into zinc oxide. So now the zinc oxide should be reduced to get zinc. This process is done by carbon. Why do so? The carbon is nothing but coke. The coke is more reactive than zinc. So what happens? It removes oxygen from this zinc oxide. So removal of oxygen takes place in the presence of coke from zinc oxide. So zinc will be formed. Here the oxygen is removed by carbon or coke, so it is called reducing agent. The agent which is responsible for the reduction process is called reducing agent. So here the carbon reduces. Come to the next case, iron extraction. This is called hematite ore. You could see the picture here. They have added charges ore, coke and limestone. So coke is added, again carbon is added. So carbon in the initial stage converted into carbon monoxide by oxidation. Now the carbon monoxide reacts with this iron oxide ore. Here the carbon monoxide removes this oxygen, will convert it into carbon dioxide, leaving behind the iron. So iron is exactly um, liquefied in the process or else reduced in this process. So carbon monoxide is responsible for removing the oxygen from iron oxide, so which is a reducing agent. So you could see the reaction Fe2O3 3CO gives 2Fe plus 3CO2. So the iron is reduced here from iron oxide using carbon monoxide. So for such a cases, zinc, iron, lead, copper, we use coke, carbon monoxide and hydrogen to reduce metals from their metal oxides. What about least reactive metals? The least reactive metals like mercury and silver are first converted into metal oxides, and then if you just heat it, the oxygen from the metal gets evaporated to the atmosphere, the metals can be extracted. So the least reactive metal can be extracted by just heating their oxides. Now platinum and gold, they do not form oxide, that means they not at all reactive. So in the atmosphere, in the earth crust, they are available as a gold and platinum as it is. Gold available in the form of gold, platinum available in the form of platinum. So they are available in the form of free state we call native state. So they do not form any oxides. So they are very least reactive metals. So if you come across aluminium extraction, what is the extraction of metal from their, what is the procedure used for extraction of metal from their metal oxide? Electrolysis. So this is what you should know. Come to the iron part. Iron, extraction of iron. Do you use electrolysis? No, which is present in the middle of the series. So I want to use any reducing agent such as coke, carbon monoxide or hydrogen to reduce to metal from their metal oxide. That is iron from iron oxide. What about if we have a ore in the mercury or silver? If it is the case, just heating their oxides will give you a metal, right? So this is what you have to understand, my dear children. So this reactivity series helps in predicting what procedure you want to choose to extract the metals from their metal oxide. You could see the bottom reactivity series, that is nothing but mercury. In this, mercury from mining is treated with powdered ores. After converted to powder, it just done the roasting process, HGS, okay, HGS, and then this roasting is done, HGS converted into HGO, and then it's vaporized. The mercury gets vaporized, and then it gets cooled. Condensation process takes place. So the mercury vaporized vapors converted into liquid mercury. So this is what happened. So we can easily extract. So just by heating, so the mercuric sulfide on roasting gives mercuric oxide. Mercuric oxide on heating gives vaporized mercury vapors. When on condensation, it gives mercury liquid. So this is how the mercury is easily done, easily extracted. So here the process is heating alone, nothing else is used. So top of the reactivity series, we use electrolysis process. In the middle of the electrolysis series, we use reducing agents such as coke, carbon monoxide and hydrogen. Whereas in the bottom of the series, we just heat this. The very bottom, nothing can be done because the metal available in the form of metal. So we can easily extract. I hope this idea is very helpful in the extraction process, right? If you like this video, subscribe and click the bell button to get the notification instantly. Like, share and comment if you have any doubt. Thank you so much, my dear children.